The last section of Chapter 9 that we will cover is 9.7, which is on probability. Okay, the probability of event will occur is the number of positive outcomes of that event over the sample space. Okay, so a basic example is when you roll a single dice or die. It's that little cube that has the 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dots. Okay, the number of faces that have a 2, there's only one face that has a 2. The total number of faces on a dice is 6. So the probability of rolling a 2 on a single dice is 1 out of 6. Okay, now for part B, the probability of rolling an odd number. A dice has, you could roll a 1, a 3, or a 5. So there's 3 positive outcomes. There's a total of 6 possible outcomes though, because there's 6 faces on the dice. I simplify, so the probability of rolling an odd number is half, which makes sense because half the numbers are odd. Okay, now let's consider the probability of A or B. This symbol means or. So the probability of A or B happening is the probability of A happening plus the probability of B happening. And then you minus the probability of A intersecting B. So you minus the repeats. Okay, so for an example, we're going to use the deck of cards, which I have displayed to the right. I tried to. Okay, now for the probability of a heart from a standard 52 card deck, well, what are the positive outcomes? The positive outcomes are I get a heart. What are all these? There are 13 hearts in the deck. There's 13 hearts out of a total of a 52 card deck. So 13 out of 52, which I'm going to simplify, which is 1/4, which makes sense because there's 4 suits. So pulling a heart, you have a 1/4 chance of pulling a heart. Okay, for B, it's what's the probability you draw an ace or a king. Okay, so we're starting to look more at this scenario, kind of. Okay, let me see. What is it? An ace or a king? So the probability I will draw an ace or a king. What are the positive outcomes? Let's see. Let's say I pull an ace. Well, there's 4 aces out of 52 cards. Plus, what's the probability I will draw a king? Well, there's 4 kings. That's the K out of 52. This rule says I need to subtract any overlapping things. So what's the probability I will pull a card that has an ace and a king on it? Well, there's no card that has an ace and a king on it, so that's irrelevant in this particular problem. So I get 8 over 52. I'm going to simplify this by 2 fours, 2 over 13. And keep in mind that WebAssign does sometimes ask you for a decimal instead. Okay, now for C, what's the probability you draw a diamond or a king? Okay, let me write it out, the notation of it. So a diamond or a king, no, a queen. Okay, first let me consider the probability of a diamond. There's 13 diamonds, so 13 out of 52. How many queens? There's 4 queens. Okay, now I do need to subtract any intersecting values. So are there any diamonds that are also queens? Yeah, there's this one right here. So I'm going to subtract off that one value, and that's because I counted it in the diamonds and I counted it in the queens, so it got double counted. Okay, let me simplify. 13 plus 14. 16 over 52, divide by 4, I get 4 out of 13. Okay, let's do one more of this or this. So probability of a spade or a face car. Spade or face. Okay, which ones are the spades? The spades are these ones right here. There are 13 of them. If you're not familiar with cards, a face card is one that has a person on it or a face on it. So the J, Q, and K stand for Jack, Queen, and King, and all those have those little royal faces on it. So there's actually 12 cards that have faces on it. Okay, now I need to subtract any cards that have a spade and a face because I counted them twice. So did I double count any? Yeah, I double counted all of these because I counted them as a spade and then I recounted them as a face. So let me subtract off those 3 repeated values. So I get 22 over 52, which I will simplify to 11 over 26. Okay, the next scenario is the probability of A and then B. The probability of A and B is the probability of A times the probability of B. So on the last example, we were pulling one card, and we were finding the probability that it could be this or this. In this case, we're probably considering more than one event happening. And what's the probability that all these events will occur at the same time, or one then the other, either way. Okay, so first we're going to consider this made-up situation of a bag of marbles. Okay, so consider a bag containing 3 red marbles and 7 blue marbles. This gives me 10 total marbles. Okay, we're going to assume that the probability of picking any marble is equal, like they're the same size, the same weight, the same everything. Okay, so but the probability that they are both red. Okay, well, the probability that one of them is red is 3/10. Okay, and then they say you put it back in and you pull again times 3/10. So the probability I pull 2 different marbles, they're both red, is 9 over 100. Okay, now for part B, we're gonna again try to get 2 red marbles, but this time we're gonna say this is without replacement. So I'm gonna take out 1 marble and I'm not gonna put it back in and then do a second pull. I'm gonna pull 2 marbles and they're gonna be out of the bag after I pull them. Okay, so in this case, for the first marble, it's still 3 out of 10 probability I'll get a red. But for the second marble, if I take 1 red out, well, now there's only 2 red marbles left in the bag. Not only are there only 2 marbles left in the bag, but there's now only a total of 9 marbles in the bag. Okay, so it's 3/10 times 2/9. I can multiply this out and simplify it, or I could do cross canceling. I think I'm going to cross cancel. Let's see, because I can see that this goes down by 2, and I can see the 3 and the 9 go down by 3, and I'm trying to be lazy. This will go down to 3, 1. So I get 1 over 15. You could also do 6 over 90 and then simplify it afterwards. Okay, now the third scenario for example 3 is I'm going to probability I will get a red, then a blue, also without replacement. Okay, so the probability I will pull a red is still 3 out of 10. Okay, now what's the probability I'll get a blue? Well, how many blues are there? Well, there's 7 blue marbles. Okay, but I already took out a red marble. So now instead of there being a total of 10 marbles, there's only 9 marbles left. Okay, I could cross cancel or I can multiply and simplify. I'll multiply and simplify this time, even though I do prefer to cross cancel. If I divide by 3, I get 7 over 30. Okay, now what does probability have to do with combinations and permutations? Well, a lot of times when you're calculating probability, you need to consider all the possible combinations and permutations of a scenario. So for example, the probability of winning the lottery. Okay, we're going to consider the lottery. We're going to assume the lottery pulls 6 numbers 1 through 50. Okay, what's the probability you will match all 6 numbers for the $1 million prize? Okay, so I'm going to set it up 2 different ways because like so many things in math, there's more than one way to set it up. Okay, so how many winning combinations are there? There's 1 winning combination. How many total ways are there to pull the numbers? Where there's 50 numbers, I'm going to choose a combination of 6 of them. So 1 over 50, choose 6. I'm going to put 50, choose 6 in my calculator. Okay, and then part of this lottery, it would be, the probability would be 1 out of 15,890,700. Okay, now let's consider some other scenarios because maybe you don't want to just, you're probably not going to win the jackpot, but maybe you will win some money. Okay, so the next scenario is you'll win $1,000 if you can match exactly 4 of the numbers. what is the probability of this occurring? How many numbers are there? There's 6 numbers in total. So I'm trying to get 4 right. If I'm going to get 4 right, I have to keep in mind that I have to get exactly 2 wrong. I can't accidentally get a 5th number or a 6th number because I might win like so much money. Okay, this is going to make our calculation a little different, although the denominator is going to be the same because they're still picking 6 numbers out of the 50. Okay, now I need to think about how many ways can I get 4 right. So of the 6 numbers, I want to see how many ways I can pull the 4 numbers perfectly. Out of the 6 correct numbers, I want to pull 4 right numbers. Now, how many are the wrong numbers? Okay, if 6 of them are the right numbers, 50 minus 6, then 44 of them are wrong numbers. So of the 44 wrong numbers, I want to pick exactly 2 wrong numbers. Okay, now I'm going to put this in my calculator. 6 choose 4 is 15. Okay, the denominator is still the same. And this one does say round to the something. So let me put it in my calculator. I get 0.123889. Okay, so as a decimal, this is how likely I am to match exactly 4 numbers. Not great, but probably better than part A. Okay, the third scenario is you're guaranteed a prize if you match at least 3 numbers right. Okay, if I'm doing at least 3 numbers correctly, I might get 3 numbers, I might get 4 numbers correct, I might get 5 numbers correct, I might get 6 numbers correct. So this gives me a much better chance of winning, but it also makes my math problem much more complicated. Okay, now the nice thing is my denominator is still the same. Okay, now we're going to go through and consider each of these scenarios and write them out carefully. Okay, first let me think. If I get exactly 3 numbers correctly, that means of the 6 correct numbers, I want to pick exactly 3 of them. Okay, but that also means if I'm getting 3 correct, I have to get 3 wrong. So there are 44 wrong numbers out of the 50, and I need to pick exactly 3 of the wrong numbers. Okay, now let me go up. Let's assume I get exactly 4 correct. If I get exactly 4 correct, then of the 6 correct numbers, I'm going to pull exactly 4 of them. But out of the 44 incorrect numbers, I have to pull exactly 2. Okay, let's see, I got 3 right, 4 right. Let's see if I get 5 right. Okay, if I get, of the 6 correct numbers, I want to pull exactly 5, which means of the 44 incorrect numbers, I want to pull exactly 1. Okay, now what if I get all of them right? Okay, of the 6 correct numbers, I'm going to pull all of them. I could multiply by 44, choose 0, but that doesn't make a difference. Okay, let's put this in our calculator and see what we get. Okay, and you'll notice that actually this number is exactly what we got up here. This number is exactly what we had for our numerator here, so we could have used our previous answers to help us a little bit. Okay, and then we'll go ahead and round this to the nearest thousandth. Okay, so the probability I'll match at least 3 numbers and earn some kind of prize is 0.018, which is actually close to 2%, which is not good, but it's better than some of the other options.